Okay, this problem is a little bit similar to the last one. So again, we're looking at a plate with a constant thickness and we're assuming it's got constant density. So therefore we can use the equation for finding the centroid of a composite shape using the formula that's got area in it. If it wasn't constant thickness or it wasn't constant density, then we wouldn't be able to do that. We'd have to use the formula that had either mass or weight. Okay, so we can use that. The main difference this time is that we've got a couple of holes in this plate. So rather than adding together composite shapes, we've got, or rather than adding together simple shapes, we have got a simple shape, the rectangle, and then we're taking away two other simple shapes, these two circles. Quite easy this time. So again, I've drawn this out. Shouldn't really have had that on there. Let me just get rid of that just now. What we'll do is we'll just think about this practically first. So think about the center of gravity of the whole shape. So we're going to have a center of gravity for that rectangle if it didn't have any holes in it. So that would be easy enough. It would just be at the center of the rectangle. And so if you were to put your finger under there and balance this shape, then what you'd find is if it was just a rectangle, that would be the balance point. Now if we drill a couple of holes in it, this side gets lighter. And so if you tried to balance it there, this side would go up, that side would go down. So what you're going to have to do is you're going to have to move this center of gravity of the composite shape, or the centroid of the composite shape, which is the same as the center of gravity of the plate. It would move across this way a little bit to make it balanced. So we're just thinking about this practically before we start. And I just reviewed some of the other videos. I'm not very careful about when I say centroid or center of gravity. I'll try to be more careful. So the centroid is for when you're talking about the two-dimensional shapes, and it's the same as the center of gravity of the plate with constant thickness that's got that shape. So centroid, 2D shapes. Center of gravity, you should be using that for three-dimensional objects. I'll try and be a little bit more careful. Okay, so what I'm going to do is I'm going to do the same as last time. So we've got these dimensions. I'm going to translate those to X and Y positions on this diagram. I'm going to put on my little red centroid, if I'm talking about the shapes, little red centroids for each of the simple shapes. And what we're going to be calculating is the centroid of the combined shape. So the centroid once you've taken out these two circles, and that'll be the same as the center of gravity of a plate with two holes drilled in it. So let me work through that, and then I'll come back to you to explain what we do next about dealing with the fact that we're actually taking away these holes, taking away these circles rather than adding them. Okay, so I'll be back in a minute. So that's the positions, the X and Y positions of each of the centroids of the simple shapes. And so all I've done is, well, these ones are quite easy. The centroid of a rectangle is at its center, to where the diagonals cross, just at the center of the rectangle. And for a full circle, the centroid is just at the center of that circle as well. So pretty easy to find. You don't even have to look at the standard equations, the sheet we were looking at before. And then I've just used the dimensions to find out where things are. And so, for example, for this centroid of hole 2, well, this is 10, this is 20, 30, 40 minus 30 is 10, so the distance up must be 10 millimeters. Excuse me. And the distance in the other direction, we've got 70, take away 10, take away 20, so the distance that way must be 40 millimeters. That's all I've done there. So the next thing we do is let's go through and calculate all of the different things we need. So we're going to need to, we've already got the X components and Y components. You don't even really need calculations for those this time. Just going to calculate the areas of the simple shapes. So it's this whole rectangle before you take the circles out. And then I'll come back and do the next bit. So I'll just stop there again. So all I've done so far is I figured out the positions of each of the centroids of the components, and then I figured out the areas of each of the centroids, the area of each of those shapes. And so now we're getting to the point where we're starting to combine things, and this is where we have to be careful. So we're subtracting these two circles. So when we add up the areas, what we have to do is we have to do A1 because that's there, but we're taking away A2 and we're taking away A3. And so we just need to be careful about that. And so the total area is going to be 2800 subtract 308.1 subtract 308.1, which is equal to 2184-ish, 2184 millimeters squared. There's one other thing I wanted to mention. The 22 seems like a bit of an odd diameter for a hole. What this will be is this will be for a 20 millimeter bolt. So what you would usually do is you make your holes for a bolt 2 millimeters bigger than the bolt itself, down to a certain size, and then you make them 1 millimeter bigger for smaller bolts. I think it's down to about 12 mil, and then you use 1 millimeter clearance after that, something like that. And so that's why this is 22 mil. Okay, and so now what I'll do is work through the rest. So I might just do them each separately. So again, when we're doing, I might just bring this across here. It makes a bit more sense if I'm going to write them all out this way. I'm not going to do the full equation yet. I'm just going to do the sum. So the sum of the x position of the centroid of each simple shape times the area of each simple shape. So I'm just going to write it like that. Sum of x's times it. But what I'm going to do is when I actually do that addition, I'm just going to be careful about whether I'm adding it or taking it away. So for x1, that's the whole plate, so we're going to be adding that on. So it's going to be 35 times 2800, and then we're going to be taking away the, it might be better just to write that out so people who are reading this without listening to me witter on know what I'm talking about. So it's going to be the position of the centroid of shape 1 times the area of shape 1. Then you're going to take away the position of the first circle centroid times the area of the first circle centroid, and you're also going to take away the position of the second circle. So that's x3, take away the area of the second circle. So we're timesing those together and we're subtracting this time. And similarly, when you're looking for the sum of y position times the area, it's going to be y1, a1, take away y2 because we're removing that shape, take away y3, a3. So I'll just calculate those, and then we'll just get our final answer. Okay, so I calculated both of those. I did an Excel again, just speeds things up, and I just used that to check some of my previous answers. Noticed I'd made a mistake with this one, so I fixed that. So we've now figured out the sum of the a's, just remembering that it's sum of a, but you have to subtract things that are getting taken away. And similarly for the sum of x position times area, you also have to take those away if you're subtracting something from the shape. And so therefore we can just figure out the final now, and so the position of the centroid of the composite shape is just the sum of x times a over sum of a, and we'll figure that out, and the y is equal to the sum of y bar times a over sum of a. We'll figure that out, and then we'll have finished. I'll write my answer and we're all done. Okay, so that's complete. We've got our answers. And so where is this thing ended up being? So the centroid has ended up being, let's have a look. So the y position is at 20 millimeters, so it's sitting on this line. Now that makes sense because you've taken away this hole, which is the same distance from that as this hole. So you've kind of taken away equal weights on both sides when we're thinking about the plate. And so that center of gravity in terms of the y position hasn't moved. And if you were smart, or if I was smart, you would look at that to start with, and you wouldn't even have to calculate this, do all the calculations with the y components. or the Y positions of all these centroids. In terms of X, it's ended up at 29.4, 2030, which is about here, which makes sense to me. And so it's just shifted this back a little bit because you've taken away these holes compared to the rectangle itself. The centre of gravity shifted back a little bit. And because you've removed these holes, you've had to reposition to get the weight equal on both sides, and to take a little bit less of this side, a little bit more of that side, so that you can counteract the loss of the mass of the material that was in these holes. So that's that one done. But one more to go, and then we can get on with the next topic, which is distributed forces. So one more to go. Put that back.